Hey guys, good evening everybody, and in this video we are going to talk about how would you approach on developing a platform or a system that allows you to schedule Spark jobs basically on EMR, right? How would you basically do error handling? How would you want to design it, right? So I will be sharing certain insights in this video. Again, this is inspired a few years back. We did something similar. We were experimenting, other stuff for scheduling, right? And basically, we developed our own system for, scheduling jobs, monitoring jobs, error handling, etc., etc. So this video, I will basically share insights on what we did on AWS Batch that you can apply here for EMR jobs as well. So let me share my screen. Again, this is more like just like a chalk talk, I would say. So let me share my screen first of all. All right. So again, our system that we developed today runs 8,600 jobs, 300 parallel jobs every single day, and about 100,000 jobs a year. So that's the volume that we are talking about. So we had a massive success, and you could apply these similar concepts for automating or maybe submitting Spark jobs, right? So let's just talk about that, right? So what I want, right? I have my EMR cluster, right? And basically, I want this is the guy, right? So I want him basically a way to schedule the jobs on a time interval, right? Let's say he wants to run the job at this time every day or every night, whatever that is, right? An ability to manually also fire jobs if needed, right? So that's something that he want. And then basically error handling, right? So the three things we want. How would we approach this, right? So we can break this into three different components. The first part would be scheduling, right? The second part over here would be monitoring, right? So we have to do monitoring and process monitoring. And the third job would be basically the metadata part. So I'll basically talk about that. So again, whenever you submit a job, a Spark job, right? Basically, you will have a job name, you will have a job description. So now let's think of like a platform. If you had to develop a platform, how would you approach it, right? So it's pretty straightforward. What you can do is you will have a UI, a single page app, which will be hosted on S3. So your data engineers or your people will essentially go to the website and they will be authenticated via Cognito. And here what they would do is basically they'll fill out a form. Here they will put the job details, the job name, the cron whenever they want to do, and then here there will be a button called upload where they can upload their Spark Python files, right? And as soon as they hit the submit button over here, right? This submit button will basically, once they hit that, it will hit a microservice, and this microservice will store the metadata in DynamoDB. So basically, we know what is the job name, we know what is the job description, when they want to run it, right? So all that detail would be saved on DynamoDB. Then what happens is we basically create a once we store the job in the DynamoDB, now basically we create an event bridge rule, right? So at this point, what happens is that cron will basically the rule is all set. So anytime the job fires up at the cron, so basically now this will fire up a Lambda function. Now this will also pass in the job ID. So basically what I'm saying is once the user has submitted the form, right, they have essentially entered all the detail. So let me show you this. This will make sense, promise. Okay, so here you see when we design the system, we have a job ID, which is a unique identifier, a job name, description, cron, S3 folder path, which means where your Spark job is saved, the Python file, right? And all that information, right? Now, whenever the event bridge will fire up a Lambda, this number 12, let's take number 12. This number 12 will be passed to the Lambda. The Lambda will go to DynamoDB and fetch the metadata and will submit a job to the EMR cluster, right? So now whenever the time comes, it will fire up a Lambda. Lambda will pull the metadata and basically pass on to the EMR job. Your EMR job will have a template, a generalized Python code. The job is to read the metadata and then download the Spark file or the Python file and then basically execute that in Python at runtime. And basically all the process monitoring and everything will be baked into that template. So for example, anytime your Spark job runs, so I want to show you this. We have that, right? So I'll just quickly show you. So anytime a job runs, you will have a process ID. A process ID will have a start date and an end date. Anytime a job failed, you will have a status, right? And also the error message, why it failed, what exactly failed in your code, right? So everything will be captured. And what you can also do is now, by enabling streams, you can broadcast these events into Kinesis, and a Lambda will process these. Anytime a Lambda encountered a status has failed, automatically it will basically broadcast a message to the SNS and an email is sent. So now you have a way to monitor, basically process monitor your jobs, right? So anytime your Spark jobs ran, it will be in pending state. Anytime it failed, it will mark the process as failed, right? And it would send up an alert to the person, right? So that's basically, so when you have the process capture system, right? And then here is the alerting module. So basically, anytime job fails, it will send up alerts, right? So that's great. Now basically, if you come up on the screen, so here you can see, right? So again, this is when the user will submit the form, right? It will hit the API. So again, as you can see, these are batch job 10, batch job 11, batch job 17. So these are event bridge rules, and these rules will pass number 10, 11, 12, 13, 14, etc. So basically, it will just pass the number to the Lambda function. So if you observe here, for example, batch job 17, if you observe this carefully, and if you see, the trigger is a Lambda function, right? So basically we'll pass that number to the Lambda function. Now coming back to the architecture here. So basically your Lambda will pull up the metadata and then basically submit that to your EMR. So we basically will submit the job. And what you have to do is, in the EMR, is you just have to basically come up with a generalized template. So the template has to be smart enough, and the template has to basically pull the Python file and then execute the Spark Python file, right? And anytime something happened, basically either anything failed or everything was okay, it will essentially update the metadata in the DynamoDB, right? So that way, now what you did is basically, now you have a way to schedule jobs, right? So anytime, so what I'm trying to say is, your data engineers are now basically just interacting with the forms, right? This is a single page app which is hosted on S3, and the registered user can come via Cognito. They can register themselves, and anytime they want to add a job, or they want to tweak a job, or they want to update a job, they log in, they put the information, they hit the submit button, the metadata gets updated on DynamoDB, the event bridge rule is set for that, and then when the cron happens, it fires up a Lambda, the Lambda pulls the metadata, after pulling the metadata, it submits the job to the Spark, and then this is the Spark job, or this Python job will be generalized. It will basically pull the template from S3 and it will execute. And basically then, as I said, right, for your error handling, you can broadcast all your process metadata to Kinesis, and a Lambda can listen to the status failed. If it sees a status fail, it broadcasts to the SNS and the person gets notified. So what we are basically trying to do here, again, if it sounds complicated, it is actually really not. So what we are thinking here is to develop a platform or a system, right? So instead of doing it manually, every time you want to have a job, somebody goes upload to the S3 and then submits a job. It's tedious, right? You want to have a form or a UI which is easy. All you do is enter A, B, C, D, do some configuration, submit, and everything happens in like a magic in the background, right? That's what you want to do, right? Not going in SSH every time and doing all these stuff manually. That's not what we want to do, right? So we took a similar concept, again, as I said, while designing the batch framework, right? So that's that. Now, if you want to take things further, right? If I want to you can also store basically Python modules, right? For a particular job, right? Each job will have several Python modules. So if you want to use external Python packages, you can install them at runtime. You could basically develop your own data. It's like a platform, right? It's more like a platform now. So again, you have the flexibility to choose which Python you have, and here you can also go a step forward, and basically each job will have its resource. So think of resource as each job you can specify how much executor you want, how much Spark executor we want. So now all you're doing is you're controlling everything about a job And all that metadata is basically saved on the on either relational database or Dynamo. It doesn't really matter, but the concept is important, right? So now what we have just done is we have just developed a generalized framework, right? You can also push the logs to S3. So if anything goes wrong and if you want to dive deeper, you can store the raw log. You can use Python logger and then push the log at the end to S3. That way you can even go to S3 and basically pull up your log file. So this is, we are talking about developing a platform, right? Which allows so what are the benefits of the platform? This platform will allow a user to come in easily, submit jobs, schedule jobs, monitor jobs, everything is taken care. So there's no tedious manual effort. It's completely automated, and all the user does is basically interacts through the UI. And there could be maybe a director or a manager who's basically supervising the job. You could build an analytic dashboard. So on a day, you can see overall how many jobs ran, how many jobs failed, what was the count, etc., etc., etc. Again, that's it. This is a small chalk talk. I hope you liked it. And if you want more videos or chalk talk like these, let me know in the comment section. I'll be more than happy to do so. That's all I have for this video. Thank you so much for watching. Keep smiling, and I'll see you in the next video.